Hi everyone, in this video I'm going to show you guys how to use the TI84 to find the best equation for the regression line, and also we're going to find a value that's called the Pearson product moment correlation coefficient, or simply the R value. I'll show you guys how to accomplish these two tasks in this video. Okay, so please have your TI84 ready. In the previous video, I showed you guys how to create a scatter plot, and also we need to have a mean point to help us to find the regression line. Right? And the regression line has to be a line. The regression line is a line that passes through the mean point, at the same time making sure that the line is sort of closest to all of the points. Right, and a good way to do that is to make sure you have equal number of points above and below the regression line. And then also I challenged you guys to use this point slope form equation to find the equation of this regression line. I hope you guys have done that. If not, please try and do it, and if you need help, let me know. Okay. Now let's take out your TI84 and let's try to use our TI84 to help us to find these two things. So here, what I have done is this is my TI84, and if you go to your stat, go to your edit list, edit, you can see that I've already have this table, the temperatures and the ice cream sales in my respective columns. So please go ahead, take your time, and enter this 12 sets of data in your calculator. Pause the video and enter them into your calculator. Okay, welcome back. Make sure you check your values, because sometimes if your values are off a little bit because of typo, and then so your answers will be inaccurate. It could be wrong. Okay, so first let's try to find the equation of the regression line. So TI84 is very powerful. As we've seen that TI84 can do a lot of stuff for us, and finding the equation of the regression line is one of them. So what you have to do is go to your stat and go to your calc. Now, even though we're talking about two variables here, which is the temperature and the ice cream sales, so we're not gonna do number two, the two variable stats yet. We're not doing that because we're not in loop. If we do that, we'll be talking about mean, median, mode, and standard deviation and all that. Right now, I'm not interested in that. I'm interested in the equation of the regression line, which is your number 4, line reg, right? Ax plus b. So once you choose number 4, it's going to give you an equation, and that is the equation of my line. Okay, that's the equation of my regression line. So go to number 4. They want you to choose your x list and your y list. So we have to be careful with what's on my x-axis and what's my y-axis. In other words, which one is my dependent variable? My dependent variable should be my y. My independent variable should be my x. All right, independent variable for x, dependent variable for y. In this case, you can kind of use we can use our common sense. Does temperature depend on ice cream sales, or is it ice cream sales depending on the temperature? It should be my ice cream sales depending on my temperature. So my temperature will be my x, which is my graph over here. Right? The graph over here, my x is my temperature, and the ice cream sales is my y-axis. So when you're using your calculator, you have to make sure that your L1 and L2, you need to know which one's your x, which one's your y. So here I already have my L1 in there. You might not have that, so just go to second stat, which will bring you to list. You just go to L1. Okay. For the y, that's my L2, so second stat, and just go to L2. Okay. Now, frequency list. Sometimes we might be counting, sometimes we're not. In this case, we're not. Right? So we can just leave that blank. Store regression equation. So store regression equation. So in this case, where do you want to store the equation? So typically, we will have my equation stored in my y equals 2, right? If I click on y equals 2, that's going to bring me to y1, y2, y3, y4, and so on and so forth. So I want to, let's say today I want to store that in my y1. So go to my vars, go to my y vars, go to my function, and let's say today I want to store the equation under y1, select y1. So there you go. So the TI84 is going to find the equation, and it is going to store the equation in under y1. All right. Now you just calculate. There you go. Now, on your screen, you should be able to see y is equal to x plus b, where your a is 30.1, approximately 30.1. Your b is approximately negative 159.5. Right, approximately. So we have the equation already. Some of you guys might not have this r squared and r. Right, some of you guys have only the equation, the a and the b, not the r squared and r. If that's the case, there's one extra step that you need to do. Okay, so go to you see this catalog right here, the blue catalog. Go to second 0. So the catalog is like, it is literally like a catalog. All of the stuff that you can do on this calculator. And what we're looking for here is diagnostic on and diagnostic off. So you kind of just keep on going down, and then eventually you'll get to D, and then there you go. This is what we're looking for. Make sure your diagnostic is on, right? Diagnostic on, and then just enter again. So it's going to say done. And now we're going to do the regression line again. So go to calc, line reg. My L1 is good, L2 is good. Store equation, let's put that on the y1. And calculate. There you go. So now you should see your A value, B value, and your R squared and R value. The R squared is not something that we don't really. R squared is not of our interest in this class. Okay, we're looking at the R here. So my R is 0.9575, blah blah blah. So now let's answer the first question first. The equation of the regression line is this. Right, that's the equation of the line, and the R value. Oh, sorry. The R value is approximately 0.958. So let's look at, let's learn how to interpret the R value first. So if the R value is something that's very close to 1, that means it's very strong. So you can refer to this table here. If your R value is something between 0.75 to 1, then it is considered as strong correlation. If it is a value between 0.5 and 0.75, it's considered as moderate correlation. 0.25 to 0.5, that's considered weak. And if it's between 0 to 0.25, it's very weak. Now, be careful with this. We're talking about absolute value of R. Absolute value of R, right? We're all talking about absolute value of R. Why do you think they have the absolute value sign? Think about it. We have, how many types of correlation do we have? Overall, we have positive correlation and negative correlation. Right? So the absolute value bar, the absolute value sign will take care of it. So if it's something that's positive correlation, your R value is going to be positive. If it's something that's negative correlation, your R value is going to be negative. But it doesn't matter because we are going to take the absolute value bar of the R value anyway. Okay, so just keep in mind that we must have the absolute value bar for the R value, and then if it's within the boundaries, that represent the respective strength of correlation. Okay, so here we have 0.958. This is positive correlation, as we can see from the graph. Right, this is positive correlation, and also it is pretty strong, right? Because the R value is almost 1. Okay. Now for the equation, we have used our calculator to get the equation. So now if you go to your y equals 2, you'll be able to see the equation of it stored under y1. This is my equation. We don't really need the exact whole thing, so typically we can round it up to about 3 significant figures, or I would recommend you guys to round it up to for intermediate workings, round it up to maybe 4 decimal places, just in case. So and then you can round it up to 3 significant figures for your final answers. Alright, so I'm going to change this a little bit. So that should be 30088. 30088. 3 decimal places. And then this will be, for example, that will be 159.474. 0.474. Okay. Now let's say why are we so interested in this equation anyway? Because if you recall, my x represent what? My x represent the temperature, right? That's my x-axis, and my y represent the sales. My y represent the sales. So if I want to know, let's say today, it's very hot, it's very warm, it's a very hot summer, and the temperature is approximately, let's say that is 40 degrees. It's very hot. It's a very hot summer, right? Right. So it's a very hot summer, 40 Celsius. Where's that? Okay, doesn't matter. 40 degrees Celsius. Okay. So now, if I want to predict what my ice cream sales is going to be, what I can do is I can just substitute this. I can just simply substitute the x in there. Substitute that. That becomes 40. That becomes 40. And my answer will be, and then we can just put that in my calculator, right? And my answer will be 1044.046. Alright, so my final answer is gonna be maybe something like y is equal to 1044, something like that. So it depends. Depends on what the question is asking you to round it up to, right? So that's it. So when my temperature, if my temperature is about 40 degrees Celsius, my ice cream sales will be approximately $1,040. Okay, so something like that. All right. So this is how the equation is useful for us. We can use it to make predictions, right? And also, the R value tells us the strength of the correlation. Hope you guys find this video helpful. I'll see you guys in the next video. Bye bye.